Okay folks, today we're looking at the sine graph which was dealt with in grade 10 extensively and just showing you where the shape of the sine curve comes from. Okay, we know that our sine of 0 is 0, and we can find that if we look at the unit circle that I've drawn here. Your naught line is over here, 0 degrees, remember your initial ray, and then that shows the terminal ray for 30, the terminal ray for 45 degrees, and the terminal ray for 60. So 0 is here and 0 is over there, they intersect at that point, so that's where the sine graph is grounded. Then if we go to the sine of 30, and we come across where the sine of 30 crosses the 30 degree mark here, that's where that point is going to lie. The sine of 45 degrees comes in, intersects with 45 over here. The sine of 60 goes across, intersects with 60, and then the 90 optimizes over there. And then the curve follows its route back to the x-axis. You can look at each one of these points. It intersects 120 over there. It intersects the 135 over there. So it grounds again at 180. And then continues in that fashion to complete one cycle of the sine curve. Okay, so folks, it's a unit circle. I draw my points, I join them closely. I'm going to try and do this as accurate as I can. Comes down, crosses, turns here, and then makes its way back to the horizontal axis. So that's the sine curve. Now, to remember things about this curve is very important, because you're going to understand the rest of the curves from a transformation perspective. So we know it's grounded, or the roots are at 0, 180 and 360. So these are the roots of the curve. And remember, I'm only sketching from 0 to 360. It continues in that fashion in the negative direction. So the roots of the sine graph, in other words, where it's 0 or crosses the horizontal theta axis, lies at 0, 180 and 360. The maximum point is at 90, so our maximum point lies at 90 degrees and positive 1, and our minimum point over this particular domain lies at 270 and at minus 1. Now, you heard me say that the cycle completes itself from 0 to 360. The amount of degrees that it takes for any trigonometric curve to complete one cycle, that's what one cycle looks like, is its period. For the mother curve of sine, our period is 360 degrees, and then we have one more thing to discuss, and that's the furthest point, or the furthest it moves away from the horizontal. The line of rest of this graph is this horizontal. The furthest it moves away is 1 and minus 1, and we refer to that as the amplitude of the curve. Amplitude. The amplitude of the curve is indeed a 1. Now, what you learned about grade 11s when we looked at triangles is that if I look at any right-angled triangle, and I'm going to say this here is 90, that is 30 degrees, and that is 60. And let's just label this A, B, and C for now. And this is angle A, that is angle B, and the right angle is at C. If I take the sine of 30 degrees, it is opposite over hypotenuse, so it will be A over C. But we see that that's also the cosine of 60, which is also adjacent over hypotenuse. So this is equal to the cosine of 60, the complementary ratios. Okay, so let's see. If the sine of 30 is equal to the cos of 60, then for the cosine curve, things are going to work differently. If I want to draw the cosine curve on here, I can start then at the point 1 over there. Because if this is 0, remember these two are complementary. Now in a perfect world, we can think of this as 0, and that must be 90. Okay, so the sine of 0 is equal to the cos of 90. We can't really think like that. But in a perfect mathematical world, where triangles still exist with 0 angles, we can think of it like that. Or we can say the sine of 30, which in this case is a half, is going to be the same as the cosine of 60. So the cosine of 60 will then be a half. Okay, so the cosine of 60 is a half. The sine of 90 is 0. The sine of 90 is 1. The sine of 0 is 0. Okay, so and if this angle is 0, that is theoretically 90. So the cosine will start at 1 and 0. Okay, so the 45 degrees are shared by the two curves. And then if this was the sine of 60 is opposite over hypotenuse, it's the same as the cosine of 30. So the sine of 60 is exactly what the cosine of 30 would be. Now if you follow that trend through the crossings over here, you can see where your cosine, or remind yourself where your cosine was lying on the Cartesian plane. Okay, so if I come down carefully with my pen, be careful to curve as much as possible when you draw these. They don't have straight edges or any sharp points on them. It's a gradual curve. Okay, so there's my cosine. Now, to write down what is relevant to the cosine graph, y equals the cos of theta, it optimizes in 3 points. There's 2 maxima over the domain 0 to 360. It lies at 0 and 1, and the next maximum will be at 360 degrees and 1. The minimum value would be over this domain 180 degrees and minus 1. Okay, the roots, in other words, where it passes through the x-axis, lies at 90 and 270. So where theta equals 90 degrees or 270 degrees. The period for the curve, now remember, what did we say the period of any trigonometric curve is? It's the amount of degrees it takes to complete one full shape of the curve. And that is again 360. So the period is 360, same as for the sine function. And the amplitude for the cosine function again lies at 1. Remember, the amplitude is the furthest it goes away from this line. So those are the points, folks, that you need to learn as a concept image and keep in your head. Okay, the pink again here, y is equal to the sine of theta, and the green is y equals the cosine of theta. Okay. Now, the moment you know those roots, you know these critical points that lie on the curve, what we're going to do now in grade 11 is we're going to transform these curves by looking at various translations, horizontal, vertical, as well as a horizontal stretch or a vertical stretch. So make sure that you keep this in mind.